Hi, my name is Jim, and welcome back to a new video about how to create a visual effects in Unreal with Niagara system. So before we start today, I would like to give a big thanks to Asher Zhu. He inspired me with his incredible visual effects made with Unreal's 4.24's new feature, and he also gave me a lot of help when I was trying to recreate his effects. So today I'm going to show you how to make a toon shading ribbon with Niagara system in Unreal 4.24. So if you are using an Unreal version before 4.24, you are not actually getting the new function, which allows you to read every particle's property, including its position. So idea is, if the two particles are close to each other, the ribbon between them is gonna be wide. But if these two particles are far away, the ribbons between them will be thin. So let's get started. So first of all, we're gonna create a material. I'll call it toon shading. So what I'm gonna do here is I'm gonna use a fake normal, which I made in Photoshop, and give the material a light direction so that the ribbon material, which is supposed to be a flat plane, can look more 3D. So this is the material I found online. I'm just gonna type it in. And here's the normal I prepared in Photoshop. I'm gonna drag it in. So here we are gonna uncheck this tangent space normal. And also right here, we use this node to convert the normal from tangent space to word space. So here's the fake normal we have now. And now let's create the toon shading part. So here I'm creating a light vector, which is 001, because we are giving a light direction to the material, because you cannot get the real-time light direction from the material node. So here we finished the toon shading material nodes. So as you can see, we use the light vector and dot product it with the normal. When the product is smaller than 0.5, we give it a color, and when it's bigger, we give it another color. And then to have a better control, when it's bigger than 0.9, we set it to another color. So here's the toon shading with 3 different layers. The closer to the center, the brighter it will be. So I'll set the center almost white. And set it to gray when it's a little bit off the center. So since we are using opaque, we're going to add a base color to it. And here we are creating a material instance to tweak its parameters. These are the parameters I use, but you can be creative and create your own parameters. So since we are using a fake normal, it's not working good on other shapes, but it works well on the plane. As you can see here, if I move the plane, Toon shading is also moving along, and we can clearly see the 3 layers of the Toon shading. Now let's get to the Niagara part. Here we are going to create a Niagara system that with a ribbon on it, and when we drag it in the editor, it has a trail. But as you can see here, we can't find the FX menu, which is the Niagara system, because we haven't enabled the Niagara plugin in our editor. So just go into the plugin, type in Niagara, and then check it and restart. We are back now. So as you can see, after we restart the program, you can see a new menu here, and we are going to select Niagara emitter and then create a new one from the templates. We're just going to use a very simple fountain. And here we're going to delete the spawn rate and then use this one instead. So we make the max loop count to 0 and then make the next loop duration to a very small value and then spawn count to 1. So basically it's gonna loop very fast, and for each loop the system is going to spawn 1 particle. And here we delete the initialized particle and create an initialized ribbon. We don't need all of these. We can change the lifetime to a longer value. But the most important thing is, if we are going to drag the emitter around and make a trail behind it, we need to set the original position of a particle to the emitter's position. So we set variables and set it to engine owner.position. I can get rid of all of this. And since we are going to use a ribbon, so we delete the sprite renderer and then create a ribbon renderer. And right here we can put in the material we just made. Save it. So as you can see here, the emitter is not going to work in the scene, so we still have to create a system. Go here and select Niagara system. And here we add the emitter we just created to the system. And as you can see, it's working just fine. Next step, I'm going to show you how to read the particles property in the Niagara script. So right click, let's go to a Niagara module script. Make sure you check this. exposed to library so that you can find the script in the system. So here we create these 4 variables, and to be able to use the particles ID, we have to go back to the system and check the required persistent IDs. And on the left side, we hit the plus and then find the Niagara ID type of value, and then we create a new value called particles.newID, and then we find the particles ID. So somehow if we use particles.id directly in the script, it will create a bug. So we have to give this to a new Niagara ID type variable so that we can use it. But it's the same thing. So we have the particles.newID here. And then let's break it down. So a Niagara ID type of a parameter has 2 parts. The one is index, the other one is acquire tag. So we add the index by 1 and then make a new Niagara ID with the new index and with the same acquire tag. So this gives us the next particle. We subtract 1 and then make a new ID. So this will be the last one. And here we use this attribute reader to get a vector 3 attribute. Connect this. So we want to get this particle's position. The same for this one. So right now we have the particle's own position and the one before it and after its position. To be safe, I also want to check if them both exist with this logic AND. So here we have 2 very basic distance calculation to get the particle's position and then calculate its distance between itself and its next particle and the distance between itself and the last particle. We add this value together and then we time 0.5 here. So right here, this is the default ribbon width I'm using, it's 30, and then we subtract the distance, the half of the distance, to use it as our new ribbon width. So it means when the particles are close to each other, their distance are close to 0, so the new width is close to the default width. But if the particles are too far away, the width is going to get smaller as the particle's distance gets bigger. So we also make sure that it's greater than 0. So if it is greater than 0, we use the new width, but if it is smaller than 0, we just use 0 as the new width. So we connect it back here. If the particles exist, we use the new ribbon width. Otherwise, we use 0 as our new ribbon width. So we just pass down the floats to the ribbon width. It should work. Let's go back here and then use this. So here's the important thing. Right here, we have to type in the emitter name for the script to actually read the particles property. So we go here, copy, and paste it in here. So as you can see, if we go faster, the ribbon gets thinner, and if we go very slow, the ribbon is thick. So you might notice that ribbon is broken right here. That's because the system is reusing the particles indexed. So if we go to the window and select this attribute spreadsheet, and then we click the emitter, we capture, and we filter the attributes. So as you know, since the script is reading the particle that's before and after the current particle, so when the system is reusing the particles index, there will be a part that the ribbon width is 0, because it has no next particle, and this one has no last particle. So here's the part that the ribbon breaks if you compile the particle or you just leave it there for too long. So this is a bug I haven't figured out how to fix it. I will post a new video or comments in this video to share my solution if I find one. Alright, it's looking pretty good now. Let's save this and let's add some polish to it. So remember right here we have a normalized age, but we haven't used it. So we are going to use this to control the width so it goes down as the particle gets closer to the end of its lifetime. So we use 1 minus, drag it all the way here, multiply this to this. And last step, we wanted to kind of move a little bit to give him a more dynamic feeling. So we create a new script. So what we are doing here is we take the particle's normalized age, give it a sign, and then multiply it. You can change the value as you want, and then make a new vector. So this makes the particle move on the z-axis over time. And then we add it to its original position. Make sure to click this, compile, and my editor freezes. So since we are using a new feature now, it is understandable that it's unstable for now. So we're back now, and let's add the script we just made. Compile and save. I see the particles moving. So you can actually change the value to make it smaller. So that's all I want to show you today. Thanks for watching and have a good day.